Today, we're going to talk about that next frontier model, which you would think logically maybe should be called O2, but out of respect to our friends at Telefonica, and in the grand tradition of OpenAI being really, truly bad at names, it's going to be called O3. We're going to announce two models today, O3 and O3 Mini. O3 is a very, very smart model. O3 Mini is an incredibly smart model, but still, really good at performance and cost.
Now, O3 is a really strong model at very hard technical benchmarks. And I want to start with coding benchmarks, if you could bring those up. So on software style benchmarks, we have SuiteBench verified, which is a benchmark consisting of real-world software tasks. We're seeing that O3 performs at about 71.7% accuracy, which is over 20% better than our O1 models.
Yeah, I mean, this model is incredible at programming.
Yeah, and not just programming, but also mathematics. So we see that on competition math benchmarks, just like competitive programming, we achieve very, very strong scores. So O3 gets about 96.7% accuracy versus an O1 performance of 83.3% on the AIME. There's another very tough benchmark, which is called GPQA Diamond. And this measures the model's performance on PhD level science questions. Here we get another state-of-the-art number, 87.7%, which is about 10% better than our O1 performance, which was at
ARC-AGI version 1 took 5 years to go from 0% to 5% with leading frontier models. However, today, I'm very excited to say that O3 has scored a new state-of-the-art score that we have verified. On low compute for O3, it has scored 75.7 on ARC-AGI's semi-private holdout set. Now, this is extremely impressive because this is within the compute requirements that we have for our public leaderboard, and this is the new #1 entry on ARC-AGI Pub. So congratulations to that.
Thank you so much. Yeah.
So next up, we're going to talk about O3 Mini. O3 Mini is a thing that we're really, really excited about.
For O3 Mini, we'll support 3 different options: low, medium, and high reasoning effort. So the users can freely adjust the thinking time based on their different use cases. So for example, for some, we may want the model to think longer for more complicated problems and think shorter with simpler ones. So on the left-hand side, we show the coding evals. So it's like Codeforces ELO, which measures how good a programmer is, and the higher is better. So as we can see on the plot, with more thinking time, O3 Mini is able to have increasing ELO, outperforming O1 Mini. Besides Codeforces and GPQA, the model is also a pretty good math model. So we show on this plot with on this AIME 2024 dataset, O3 Mini Low achieves comparable performance with O1 Mini, and O3 Mini Medium achieves comparable better performance than O1 if we check the solid bar, which are past ones. And we can further push the performance with O3 Mini High.
But something new we're doing this time is we're also opening up this model to external safety testing, starting today with O3 Mini, and also eventually with O3. So how do you get early access as a safety researcher or a security researcher? You can go to our website, and you can see a form like this one that you see on the screen. And applications for this form are rolling. They'll close on January 10th. And we really invite you to apply.
OK, so to sum this up, O3 Mini and O3, apply please if you'd like for safety testing to help us test these models as an additional step. We plan to launch O3 Mini around the end of January and full O3 shortly after that. But that will, the more people can help us safety test, the more we can make sure we hit that. So please check it out.